Hello everyone, thanks for being here. I'm here to do a presentation. I'm Yunping Li, and I belong to Group 1. I would like to talk about sustainability. And our topic is B4. Promote green building standards for sustainable construction. The topic is composed of two parts. Compare the Taiwanese EEHW system with the top 5 most demanding green building label standards, and is any building 100% recyclable and have no impact on the climate during its life cycle? This is the outline. Many may consider a green building as a building that comes with green walls and solar panels to beautify and protect the environment. It is way more than that. Green building is a multidisciplinary subject and has a profound impact on us. Generally speaking, green building reduces the environmental impact of buildings and enhances the health and well-being of building occupants. In order to meet global carbon reduction goals, we need a rapid and far-reaching sustainable transition in land, energy, buildings, transport, and cities. Green buildings are designed to reduce the overall impact of the built environment on human health and the nature environment by efficiently using energy, water, and other resources, protecting occupant health and improving employee productivity, reducing waste, pollution, and environmental degradation. Let's start watching the video about exploring green building and the future of construction.
This episode is brought to you by Brilliant. Click the link in the description below. A lot of focus is put on generating cleaner energy for a sustainable future, but that's just one piece of the puzzle. What if we could dramatically reduce our energy consumption just by changing the way we build our office buildings and skyscrapers? Imagine a skyscraper with smart windows and walls made from fungus. Yes, fungus. Let's explore green building and the future of construction. And can going net zero really make a difference? I'm Matt Farrell. Welcome to Undecided. Building office buildings and skyscrapers with thousands of pounds of concrete, steel, and other materials is a major contributor to pollution and energy use. But it's more than that. Our homes and office buildings' lighting, heating and cooling, poor insulation, and integration into the surrounding environment have a lasting impact on the energy use and costs. They require larger amounts of power and water to keep comfortable, which just keeps going on indefinitely. Buildings accounted for 28% of energy-related CO2 emissions in 2019. In order to reduce that problem, we need some innovations around how we build our houses, offices, and skyscrapers. And this is where net zero and green buildings come in. These constructions are designed and built with the goal of creating a positive impact on the environment and climate. They can combine energy efficiency and renewable energy to reduce power consumption, benefit the environment, and improve the quality of life for the people that live and work in those buildings. Now, the concept of green building has been scaling from small houses to big offices and skyscrapers around the globe. Some international certifications have been developed in order to provide clear guidelines on how to do it. The U.S. Green Building Council developed the Leadership in Energy and Environmental Design, it's also known as LEED, to rate green buildings and provide owners with a framework for cost saving, high efficiency, and health for design, construction, operations, and maintenance. Another popular certification is the Building Research Establishment Environmental Assessment Method from the UK, also known as BREEAM. Or BREEAM? BREEAM? Who comes up with these acronyms? Well, anyway, zero energy buildings have on-site renewable power sources like solar panels to try to produce as much clean energy as it consumes. You can't always do 100%, but the goal is to get as much as you can. Now, the power generated during the daytime is consumed by the facility itself. And if there's energy surplus, the building delivers that into the grid to try to compensate for grid energy consumption at night. However, to improve efficiency, energy consumption needs need to be reduced. So heating and cooling and lighting needs to be minimized. To achieve that, it's recommended to integrate things like green roofs, energy efficient windows with triple pane glass, and good insulation. Now, net zero buildings are also considered green if they're constructed with non-toxic, eco-friendly, and sustainable materials. They should also use less water and have good air quality so it becomes more sustainable. Some of the simplest solutions you may have already seen where you work. A good start to making a building more efficient is using high efficiency LED and smart lighting, or occupancy sensors that are hooked up to air conditioning or fan systems. All of those can contribute considerably to reduce energy consumption. But taking things to the next level, engineers and architects can perform advanced analysis through 3D building energy simulation tools to achieve higher efficiencies. Some software like Green Building Studio, Energy Plus, and IES Energy Modeling enable engineers and architects to improve a green building's design in order to increase their sustainability. They can perform a climate analysis and HVAC simulations to optimize what materials to use and how to orient the building for best efficiency. They can see exactly how the building will fare throughout the year before it's even built. Examples of green and net zero buildings have been spreading worldwide over the past decade. In London, for example, Siemens has built the Crystal, one of the greenest buildings in the world. This highly sustainable building is also a unique events venue. It establishes the benchmark for sustainable building design, achieving the Platinum LEED and Outstanding BREEAM accreditation, the most rigorous standards for sustainable design. The Crystal is 70% illuminated by natural light due to its triple glazed windows, and the solar panels produce 20% of the electricity that it uses. Now, rainwater is collected from the roof and stored in an underground tank for use in the building. 100% of the water that's used in the toilets is taken from non-potable sources just like that. Another interesting feature is the 3,500 data points that are used by the Siemens Building Management System to monitor the building's efficiency, which can view water and energy consumption live. The building cost about £30 million in 2012, but saves a lot of money with electricity. Peter Daw, the city's development manager at Siemens, said in terms of CO2 savings, we're saving about 71% compared to an equivalent building. In terms of energy costs, we're saving about £500,000 a year. In Seattle, the Bullitt Center is considered the greenest commercial building in the world. Its structure is mostly composed of heavy timber, and the materials were kept to their natural state to avoid toxins in today's finishes. And the wood was sourced locally. The triple glazed curtain wall system, which creates the airtight seal, along with the orientation, provides heat control and improved daytime lighting, so the lights are basically off most of the year. In addition, a closed-loop geothermal system meets the heating and cooling load in the office, and an air-to-air heat exchanger provides incoming fresh air from the outside. The Bullitt stores rainwater in a 56,000-gallon cistern in the basement, which is treated and used for non-potable and potable uses, which means they can use it for drinking water. Now, according to Justin Stenkamp, a mechanical engineer with the company that designed the building's control and plumbing systems, these measures alone help to save approximately 80% of the water use over a regular office building. All of that is well and good for building new buildings, but what about existing buildings? One Embankment Place was built in the early 1990s in London for PricewaterhouseCoopers. It's a great example of zero-energy retrofitting, and today is one of the greenest buildings in the world. It utilizes a tri-generation combined cooling, heat, and power system that's fueled by recycled waste vegetable oil. It also has several open-plan spaces to harvest daylight, roof gardens and green walls to make the building more ecological, and low-flush toilets to reduce water use. Currently, the One Embankment Place emits 40% less carbon than a typical building of its size, and 20% of its heat and 60% of its energy needs are produced on-site. PricewaterhouseCoopers has saved £14 million with energy and carbon-related costs. Another retrofitting example is Powerhouse Jorbo, located in Bærum, Norway. I hope I didn't butcher that pronunciation, because I most likely did. Now, these two office buildings from the 80s were retrofitted with efficient ventilation, insulation, and daylight. In addition to producing renewable energy on site, the energy needs of the buildings has been reduced by more than 86%. As a result, Powerhouse Jorbo received an outstanding classification from BREEAM NOR. And probably the coolest part, the building produces about 230,000 kilowatt hours of energy, but only consumes about 100,000 kilowatt hours. With new buildings and retrofitting old buildings, what's the forecast of net zero adoption? According to one report, the global net zero energy building market share was valued at $896 million in 2018. It's expected to reach $2.1 billion by 2024. That's some serious growth that's being spurred on by not only policy, but the value that it drives for building owners. Besides reducing utility bills and zeroing out energy use, it can increase the building's valuation and isolate owners from future energy price variation. On top of that, the benefits also reach out to the people who live and work in the green buildings by experiencing fresh air and enjoying an environment more connected to nature. And there's the positive impact on the environment due to water conservation and energy and material efficiency. So if this is also great, why is it still a bit unusual to see a green or net zero energy office building? I worked in one for years here in Boston, but they're still hard to come by. The cost of building a zero energy building is higher than constructing a common one because the building materials are usually more expensive. And there still isn't a vast number of designers or builders that are highly skilled and experienced in this type of building. Also, high-rises have many spaces and occupants in a vertical building with limited roof space for solar panels, so it's difficult for all of them to produce the energy that they consume. A study conducted by the United Kingdom Green Building Council analyzed the feasibility of the design, delivery, and cost of new net zero carbon buildings. In the study, they broke it down into two buckets. For office buildings being built using net zero goals now through 2025, the cost is about 6.2% higher than standard. Looking further out at newer technologies and standards that are expected to be in the norm by 2030, the cost is 8 to 17% higher than standard. Now, some governments are rolling out policies to stimulate net zero or nearly net zero energy buildings. The EU's Energy Performance of Buildings Directive is a really good example. It established that all new construction must be nearly net zero from December 31st, 2020, so everything from now onwards needs to meet that criteria. Energy performance certificates must be issued when construction is rented or sold, and promote smart technologies like building automation and control systems. Then there's the World Green Building Council, which is a group of 70 green building councils from around the world, who have, among other initiatives, the Net Zero Carbon Buildings Commitment. This challenges organizations, businesses, cities, states, and regions to all make assets under their direct control operate at zero carbon by 2030. There are currently 94 businesses and organizations, 28 cities, and 6 states and regions participating, covering nearly 6,000 assets. By sharing knowledge and lessons learned, the initiative aims to remove the barriers to net zero implementation and inspire others to take action. In addition to green policies,
Let's move back to the topic. Compare the Taiwanese EEWH system with the top 5 most demanding green building label standards. This is a table of EEWH Green Building Evaluation System of Taiwan. The minimum requirement for green building certification is to pass 4 indicators, including 2 prerequisites: daily energy conservation and water conservation, and 2 optional indicators from among the other 7. A green building is estimated in an average lifespan of 40 years to save 20% in electricity and 30% in water, to reduce resource consumption, as well as to provide a better living environment with health and amenity. The label is valid for 3 years and renewable. By the end of December 2021, a total of 10,296 buildings or projects in Taiwan were certified as green buildings. The following table and the expanded information directly below it outlines several of the most commonly used and respected green building rating and certification system in the Taiwanese marketplace. And the following pictures visualize the table. Their countries, authorities, year of launching, and levels of classification. Each of the standards has its own manual with large amounts of technical details. The distribution of credits between the categories and details regarding the assessment. The technical details are divided into 5 to 10 categories. Each category has mandatory requirements that have to be fulfilled in order to obtain the final certification. And the other 2 countries. Let's move on to the next topic. Is any building 100% recyclable and has no impact on the climate during its life cycle? The answer is yes. Primitive houses are almost 100% recyclable buildings. For example, the houses are built of wood, clay, straw, mud, ice, rock, and so on. The left-hand corner is a primitive medieval clay house with a straw roof. The right-hand corner is an igloo which is located in Canada and Greenland. Increasingly, we have approaches that can offer highly recyclable construction. However, designing a completely recyclable building is still a mission impossible. Norwegian startup Othello developed a patent-pending technology to manufacture building systems using recycled plastic waste. Their target market is affordable housing, refugee shelters, and camps for disaster and emergency situations. For a 60 square meter house, Oslo recycles 8 tons of plastic waste. With today's amount of plastic waste, 1 billion houses can be built. The aim is to use local raw materials and create jobs in the process. This bar in Japan is built entirely from trash, executed with a zero-waste goal. The house was built using windows salvaged from abandoned homes, reclaimed floor tiles, old bottles for chandeliers, and newspapers for new wallpaper. These are our opposite views. Firstly, high initial investment. Although the returns are great over time, the initial investment is still a major problem in green buildings, which can be more expensive than conventional buildings. Depending on the number of eco-friendly technologies you want to implement in the building, the cost may even be higher and several people cannot afford the initial of construction. Secondly, restriction of location. Figuring out the right location is another disadvantage of green buildings. There are many factors that may affect green buildings, such as climate change. The buildings utilize mainly sunlight to regenerate power, so building in a region with many sunny days is crucial. Thirdly, unavailability of workers with expertise. It might also be challenging to find workers with expertise both for initially constructing the buildings and repairing them because industries like these are relatively new. These are 3 action ideas suitable for inducing change. Firstly, government subsidies and incentive policies for constructing green buildings, also requiring builders to propose long-term maintenance plans. Secondly, growing public awareness of environmental protection in the world. Thirdly, converting old houses into green buildings is more environmentally friendly than demolishing them. This is reference list. That's all. Thank you for listening to my presentation.